So in this video, we're going to go over some geometry terms. As I do these geometry terms, you should be writing them with Cami in your notes if you're at home. So you have a document, you want to fill them in as I go along. I'm going to try to keep the definitions as short as possible to make that easier for you. So our first word is point. We're also going to draw them. So a point is a location. To get into the technical definition, we say it has no breadth or width, which means it doesn't really have size. It's just a spot where I'm talking about where something is. A line in geometry looks like this. And the important thing is we see arrows on both ends. So the line goes in both directions forever. So at this point, you should have both of those terms filled in. As I have, as I said, you're going to be submitting these notes. The line segment is very similar to a line, except it does have endpoints. So it starts at a point and it ends at a point. It does not go infinitely in both directions. So it has a starting and ending point or location. So looking down the page a little bit, our next term is array. So I have a starting point, and then I'm going somewhere. So we could have array that's really going, you don't have to draw this down. You could have array starting and going in any direction, starting and going this way. Those are all arrays. So to contrast from our line segment and our line array has a starting point and goes forever. In one direction. An acute angle. So now we're going to get into different types of angles. So first off with angles, and we saw this in that video where you guys did an Edpuzzle, an angle has a point called a vertex, and then two rays coming out from that same point. So both of these rays have a starting point at that vertex. So an acute angle, like this one here, is any angle between 0 and 90 degrees. So just to contrast that, a right angle, which I kind of wish I had included in these definitions, so a right angle, we'll just write that on the side, is 90 degrees. A lot of angles in rooms, the corners are 90-degree angles. Chairs are usually at 90-degree angles. So this is 90 degrees. So when I look at my acute angle, it bends in more than the 90-degree angle. Our next term is an obtuse angle. So there's my vertex, there's one ray, and here's another one. And this angle measure is between, so any angle between 0 degrees, sorry about that, scratch that, that's the acute, between 90 degrees and 180 degrees. Okay, so it doesn't include 90 and 180. We have different names for those. The 90 is the right angle, and the 180 you're going to see is the straight angle, which is our next word. So moving on to the bottom of this page, we have a couple more terms. So we're talking about our angles. We have acute, we have our right angle, our obtuse angle, and the next one is a straight angle. So there's still some point that we would call the vertex somewhere, but in a straight angle, those two rays go in opposite directions. So this angle is basically any angle that is a straight line equal, and the measure is 180 degrees. So any angle that is 180 degrees. So our next section, which includes adjacent angles and our terms on the next page, are when we talk about multiple angles. What relationship are they? So first off, any angles that are next to each other, directly next to each other, and share a middle ray are called adjacent angles. So I'm going to start out with a vertex, and I'm going to have this red angle here. We're not really worrying about if it's acute or obtuse or anything like that. And then if this black line was the same exact line as that red line, and I made another angle this way, we would say that angle 1 and angle 2 are adjacent angles, so they're next to each other. So any two angles that share a vertex and a ray. Okay, another way I think of it is just a shared side. I mean, we use the word side more when we're talking about shapes, but that line in between angle 1 and angle 2 has to be there if they're going to be adjacent. So this is your first set of terms. We have a couple more on the next page. So our next one is linear pair. And a linear pair is a special type of adjacent angles. So I'm going to start out with one angle. So here's angle 1, and if I want to make a linear pair, I'm going to draw another angle, and that angle between the two form a straight line. Okay, so a linear pair is two adjacent angles that form a straight line. And that straight line, if I did angle 1 plus angle 2, so if I added however much angle 1 was, and we actually, when we talk about an angle, so it doesn't look like I'm putting 1 plus 2, I'm going to write the measure of angle 1 plus the measure of angle 2 equals 180. And that's because together, if I was going to erase this shared line, it would just be that straight angle, right? That would be 180. So our next term, complementary angles, are any two angles that add up to 90 degrees. So first off, I'm going to write the definition because there's a couple different ways that we could see complementary angles. So this is two angles that add up to 90 degrees. So one way you can remember this, and this will be in contrast to supplementary, which is our next term, if you draw the letter C, you could make the letter C part of the number 90. Okay, so that's complementary goes with 90. So sometimes my complementary angles could be adjacent to each other. So these two add up to 90, so maybe this one's 20 degrees and this one's 70 degrees. But I could also have any two angles anywhere. So let's say I'm talking about this angle here, which happens to be 40, and then another angle over here, which happens to be 50 degrees. Okay, and those aren't really drawn to scale. So these two, even though they're not touching each other, those are still, if 40 plus 50 equals 90, right? That's still considered complementary. Okay. Supplementary is our next term, and this one is very similar to our last one, except supplementary angles are two angles that add up to 180 degrees. Okay, so supplementary angles could be a linear pair. So if I had, and I'll try to use the same color so it looks just like the picture for number 9. If I had this angle and that angle, and this one was 110, and this one was 70, right, they're a straight line, so they add up to 180. Those are supplementary. But we could also just have random angles. Often this happens on parallel lines where those two angles add up to 180. Okay, so there are any two angles that add up to 180. So if you had 100 and an 80, those two would be supplementary. Or 10 and a 170, any sort of pair. So next, we're going to look at something called vertical angles. So anytime you have two lines, so I have one line going this way and another line crosses through it, we would call these angles, I put little dots here, so these two red ones would be vertical, and then these two here would be vertical. So they're across from each other at an intersection. So just to kind of make that clear, if this was angle 1, this was 1, 2, 3, and 4 for my angles. Angle 1 and 3 are vertical, and angles 2 and 4 are vertical. So looking at this, basically vertical angles are angles across from each other on intersecting lines. And an important property of vertical angles is that they are equal to each other. So in my picture, if I told you angle 1 was 50 degrees, you would also know that angle 3 is 50 degrees, right? Because they have to be equal. Now, because 1 and 2 form a linear pair, if this is 50, then this one has to be 130, right? Because they have to add up to 180. So I can also figure out that angle 4 is also 130 because 2 and 4 have to be equal. So you actually, in that intersecting picture, you know one angle, you know them all. So our last two terms, and these are actually going to come into play a little bit more in future lessons, but I decided to include them in the terminology. Parallel lines are any two lines that never intersect. So lines that do not intersect. We could also say that they're lines that go in the exact same direction. That's another way we can think of it. Perpendicular lines is our next one. Perpendicular lines are lines that intersect at a right angle. Okay, so they form these vertical angles. All the angles they make are 90, so it still follows our vertical angle rule where the opposite ones are equal. So these are angles, or lines, sorry about that, or lines that intersect at 90-degree angles. Another way you might see perpendicular lines, a lot of times you'll see it as a line and then just a ray coming out from some point on that line. We still kind of call those perpendicular lines, even though the one is really a ray. That piece that's moving up is a ray. So make sure you've done all of this in Kami. If you needed to go back and pause the video at certain spots, because you're going to be handing this in as an assignment in Google Classroom.